Alright team, what we're doing here is the 2020 advanced paper. This is going to be quite a long video, so you might want to skip ahead to different parts as you need to. I might even be able to break this down into a couple of little segments, multiple choice, booklet 1, booklet 2, but we'll see how we go. Alright, our first question here, our 10 multiple choice. We're approaching this paper and thinking that our first couple of multiple choice are probably going to be pretty straightforward. And then our last couple of multiple choice will be quite challenging. So don't be surprised if you look at that and say, question 9 and 10 are really hard, but 1, 2, and 3 are really easy. Well, that's kind of how it's designed. So let's have a look at this first one here. We're asked, what's the domain of this inequality? So the question is really saying, well, what are the restrictions on this function for our domain? Well, the thing that's restricting me is the square root. That everything under the square root, so everything in there, must be positive. So that means that 2x minus 3 has to be positive. Now, if we consider, should it be equal to 0? Well, yes, of course it can be equal to 0 because the square root of 0 is fine. The square root of a negative number is not fine. If this were 1 over that function, well, then we couldn't include 0 in that. But here we're absolutely fine to do so. Which means that our domain is going to be 2x is greater than or equal to 3, x is greater than or equal to 3 over 2. Answer D. All right, we've got a function fx equals x cubed. It's transformed to give me this x minus 2 all cubed plus 5. And we've got our two translations that have happened there. Horizontal translation of 2 units followed by a vertical translation of 5 units. What's happened here? The plus 5 is pushing me 5 up. So that automatically means that C and D are gone here. And my horizontal translation here is pushing me 2 units to the right because, of course, for a function like this, if I have f of x equals x minus a, that means my new x-intercept, my new term for something like a cubic function is going to be at x equals a. That's going to occur at x equals 2 here. So that means I've gone right and I've gone up. So my answer is B. We've got a Z-score question here, new content to the advanced course in 2020 and common with the standard course as well. So we're asked here, which subject has John performed the best in? Now, the cheap answer here would be just look at it and say he did the best in French and the worst in music because that's his highest and lowest mark respectively. But what we need to do here is we need to turn these into Z-scores. So our Z-scores for these 3 scenarios here, of course, the formula for our Z-scores is our score minus our mean over our standard deviation. So my Z-score in each of these 3 scenarios is, now for all his 3 subjects, he's above the mean, so I'm expecting 3 positive Z-scores here. So for French, his mean is 82 minus 70 over 8, which is 1.5. For commerce, we've got 80 minus 65 divided by 5, which is 3. And 74 minus 50 over 12, which is 2. So as it turns out, if we reorder these based on the Z-scores, that commerce is the strongest and French is the weakest. Option A. In fact, for commerce, we would be expecting that John is right at the top, probably ranked amongst the top few students here because he's 3 standard deviations above the mean. Indefinite integral here. So if I've got e plus e to the 3x, well, the thing to acknowledge here is that e is Euler's constant, which is about 2.71. So if I want to integrate e there as 2.71, well, that just becomes e to the x. So straight away, I'm going to look at this and say, I know that C and D are wrong because they've not integrated e correctly. Imagine that we turned it into this, 3 plus e to the 3x. Well, that's going to be 3x plus the component that's related to our exponential there. Now our option here is whether we need to divide or multiply by 3. We do need to divide by 3, so our answer is B, because what I need to do is divide by the derivative of my exponential function, which here is 3, so that if I were to go differentiate that whole function again, I would end up with that original integral there. So our answer is B. We've got a quadratic function here for question 5. We've got minus x squared plus bx plus 1, where b is positive. So straight away, the thing I'm looking at is I go, the y-intercept is 1. No help there because all 4 functions have a y-intercept of 1. Okay, moving on. X squared is negative, which means I'm going to be concave down. Hope you can see that a and b are gone. Now from there, what I'm looking at is trying to find, they've included this weird statement. Well, it's not actually a weird statement. It's seemingly weird without knowing what you're looking for, that b is positive. Well, what that means is I can go find the coordinates of my turn here. So I know that my turn occurs at x equals minus b over 2a. So in this scenario, I've got x equals minus b over minus 2, or b over 2, where b is a positive number. Well, that means that this is a positive number, meaning that my turn has to be at a positive x value, so C is the correct answer here. The other way you could look at this is do some calculus. You could go and say y dash is going to be minus 2x plus b. Where's that going to be equal to 0? Because that's going to tell me the x coordinate of my turn. And what I'd end up with is x equals b over 2. No surprises that these two answers are the same. They actually need to be the same, whether we do calculus or using symmetry. But again, we would find that that is going to be a positive number, so our answer is C. Question here about the range of our cosine function. First thing I look at here is this 3x has no impact on our range or in our domain. That impacts the period, the frequency, the wavelength, how quickly that wave is oscillating, but not how high or low that wave is oscillating, or the midline. So our 5 here, that's adjusting the midline, and our 2 is adjusting our amplitude. So if I have a look at this here, I'm saying I'm starting, I have a midline of 5. If my midline is 5, I'm going 2 up and 2 down from there. So that means my range is going to be between 7 and 3. We're in interval notation here. Of course, square brackets means I can get to 7 and 3. I do actually make contact with those, which of course I do. So we don't need to worry about the 3x that was here. That's not actually impacting our domain or our range here. We've got an integral question for number 7, where we've got a couple of different functions put together, and we're asked to find what's the value of this integral. Well, really, this is testing your understanding of what an integral represents, because I don't know what these functions are. You could technically go and write them. This one looks like it's y equals 3. This first one, I could then go find an equation for a semicircle and try to deal with that, but that's going to be a little bit challenging. And then I could find this linear equation here, but again, I probably don't want to have to go about trying to do that. Instead, what I can do and say is, all right, well, I know that my integrals here are going to be a sum of all my areas. Whatever area is above the x-axis is going to be positive, so all of this is going to be positive, and whatever is below the x-axis is going to be negative. I've got shapes here that I can find the area of. So if I have a look at my first shape there, that's got an area of 3 by 4 is 12. Next, I've actually got another rectangle that's 12, followed by this semicircle. Well, that semicircle's got a radius of 2. So if I have a look at my circle, area is pi r squared. So pi times 2 squared is 4 pi, halving that, which is 2 pi. And if I have a look at my triangles here, they've all got a height of 3 They've both got a height of 3 and a base of 2. Now, because this one's above the axis and this one's below, they actually cancel each other out. If we were talking about, because this question is phrased as an integral question, there's no reference to actually treating these like an area. We can just use their behavior as an area to find the value of our integral. We are still saying we add what's above the axis and subtract what's below the axis. So they do just cancel each other out. The 3 units above and the 3 units below do not count. So our answer here ends up being A, because you've got 12 plus 12 plus 2 pi is 24 plus 2 pi. I'd imagine you have answer B if you forgot to halve your circle. I'd imagine you have answer C if you added on the 3 units for each of the 2 triangles, and imagine if you got D if you put both of those mistakes in. Another calculus question here for question 8. If we have a look at what we're asked to find here, we've got values of f double dash 1, f dash 1, and f of 1, and asked to find out which order they fall in, if you'd like. So we can straight away assess that we know that if I was to draw a tangent there, that's an approximate tangent, that's got a positive gradient. So we know that f dash 1 is positive. We also know that f of 1 is positive. So that means I can assume a couple of things. Now, if I also have a look at this, I know that f double dash of 1 is less than 0 because my curve is concave down. So straight away, I'm looking at it saying that C and D are gone because these couple here are in the wrong order. Now, to decide whether our answer here is A or B, it is a little bit tricky, but we're actually going to use that approximate tangent that I have just drawn, and finding the gradient of that tangent, we notice that even my one that is not drawn perfectly, if I were to draw it perfectly, it would still look about like that. And the key things to acknowledge here is that the y-intercept occurs above the origin, and the x-intercept occurs to the left of the origin, meaning that the gradient at that point is going to be such that the function value is greater than the gradient value. If they were the same, it would pass through the origin, and if the function value were less than the gradient value, it would actually look something a little bit like this, which in this case would make no sense. So that one is a little bit tricky to get the exact right answer. I think if you're switched on, you're probably going to acknowledge it's not C or D, but our answer here is in fact A. Question 9, we're having a look at z-scores again, and we're asked which of the following most accurately represents the region in which 10% of the distribution lies, but it's not the bottom 10%. We know that based on our empirical rule, we know that 68% sits in the middle, 95% sits between those two boundaries there, and then our 99.7 sits a third standard deviation above or below the mean, which are not shown here. I'm not drawing on those for any particular reason other than just they're two normal curves that I can use. So obviously here we can't use the bottom 10%, so A is gone, and B is gone because it's the bottom and it's also very large. If I go and consider what my answer could be here, considering that in this whole section here, between -1 and -2 standard deviations, that accounts for 13.5%, and we've shaded not even half of that, so that's looking like it's probably going to be too small. So our answer is option C here. As I said at the top, I'm expecting my last couple of multiple choice questions to be challenging. Personally, I think number 8 here is challenging, as is number 10 that we're about to look at. We've got this function of a function that's going to happen, f of x being this function that's got an asymptote here, and g of x being the grade parabola there. And we're asked how many stationary points f of gx is going to have. So we need to do two things here. We need to acknowledge that what's happening here is that we're going to find our function values for g of x and then substitute those into f of x. That's what f of g of x means. So given that we've got this turn, this stationary point here on f of x, that occurs at about an x value of a little bit less than 1. Even if we would round it and say it's approximately 1, that will be okay. So that means that that new x value that's going to be substituted in is actually going to be the y values from g of x. So what I need to look at first of all and say is, okay, so that means whenever I have a value that's being substituted into f of x of approximately 1, that's going to have a turn. Well, if I'm substituting these values from this grade curve in, well, that means there's going to be a turn that happens at about there and about there. So that means that 0 and 1 are off the table here. Now, our answer is actually 3. And the third one comes from this turn here by considering our chain rule. So a chain rule says that if I've got a function of a function, and I'm raising that all to a power, to find my derivative of that, I find the derivative of the internal function and then the derivative of the external function. And both of those produce stationary points. So that's where that third stationary point comes from. The first two come from the idea that fx is going to have a stationary point wherever x is, or its input is about 1, which is the red dotted line there. And the second turn, if you'd like, comes from the turning point on the parabola. So that's how we end up with 3 turns. I'd imagine you could look at this and say it's going to be 2 by just looking, well, gx has a turn and fx has a turn. Great. Or by looking at it saying, oh, and actually getting these 2 correct, but missing that third one there.